Oh my goodness, that might be a lot more than you bargained for, but you got it. And there's more if you want to read about it here. I've got stuff, but I do want to say that please be assured you don't need to go into this stuff into detail. Your job as an AI engineer is about selecting, optimizing, tuning, and applying LLMs rather than writing this kind of PyTorch code. But it can be interesting. I think it helps to have the intuition, and that's why I cover it. Okay, enough. Let's run this model. So the way that you run the model is you just call model.generate. You pass it the inputs. These are the token IDs that are on the GPU. We say, don't make more than 80 new tokens, please. Let's print the outputs. Right now, it's going to do everything I just said. It's going to pump it through all these layers. And one thing I didn't even mention on these layers, you probably saw, is that they've got this linear 4-bit. They have been downgraded to 4 bits. If you're not using quantization, you wouldn't see that linear 4-bit. So right now, all of that's going to happen. It's going to happen while we watch. There's some warnings. We don't care about warnings. Attention mask stuff. I'll tell you about attention masks another day. And here is the output. There it is. Well, great. That's a funny joke. It's told us. Yes, this output, which is a tensor. It's on the GPU. That doesn't make much sense to us, but luckily you may remember that we can call tokenizer.decode and see what on earth it's trying to communicate to us in these numbers. And here it is, beginning of text, start header, system. And that's all that, okay. Here's a joke tailored for a room of data scientists. Why did the pandas go to the statistics club? Because they wanted to analyze their love for data, and it was a pandemonium of numbers. This joke combines a popular pandas species with a statistical concept and a playful pun on pandemonium. I mean, remember, this is a 1 billion parameter model that we've downgraded to only have 16 possible positions. So it's not, with that handicap in mind, not bad at all. I think that is perfectly passable for a tiny 1 billion parameter model at a quarter of its size. So I'd say they're nicely done. And now sometimes it's good to clean up the memory that's being used, because this stuff hangs around on the GPU, and these are some things to run. And a student helped iterate on this and get it better. So after you do this, sometimes it cleans up the GPU memory, but sometimes it doesn't. It sort of hangs around there. But I think it still has freed it up, even though it doesn't show it visually on here. All right, so I've now wrapped that generate function in this big block, in this big function here, and I've put in some more parameters. I'm making it, you can choose whether it quantizes or not. You can set the max number of tokens if you want. I've also got some stuff here about attention masks to stop that warning happening. And if you want to find out about attention masks, then do Google it, or we will be forced to talk about attention masks in week 7. So you can look forward to that. And then I'm also going to use streaming. That's just a Hugging Face feature. You can have something called a text streamer. You have to tell it which tokenizer you're using, and we will then stream back results. When we call model.generate, we pass in the streamer. But otherwise, this is the same. It's going to take a model. It's going to look up the tokenizer. It's going to have the janky pad token equals end of sentence token. Who knows why we always have to say that. It's then going to get the input IDs, turn them to PyTorch, put them on CUDA. It's going to get the attention mask, and it's going to then choose whether to quantize the model or not, get that model, and call model.generate. That's what this function generate does. And so now we can call that function for 5.4 from Microsoft. And now this is a bigger model. This is like a 4 billion parameter model. So you can see it's got like 7 gigabytes. And this takes like 5 or 10 minutes or something to come through. So I'm going to head off and get myself a coffee. And I guess the video is going to flip on right away. But if you're running this yourself, you may need to go and get a coffee too. And I will see you in just a second. Wow, and if it feels like it's been 10 minutes since you kicked this thing off, well, that's because it has been 10 minutes since you kicked this thing off. Why is it like it's a 4 billion parameter model and it runs quite quickly? It's the downloading the model that takes so long. And when you run it on your own machine, it gets cached on your hard drive. But when you run it on Colab, it has to download it every time you have a new runtime. And so let's hope the joke is worth it. Let's see. Why did the data scientist break up with the computer? Because it kept dumping data on them and they just couldn't handle the relationship anymore. And then a special end token that was well needed. It was all right. I think I preferred Llama's one. Okay, yes, then we'll move on swiftly to smaller models, starting with the absolutely tiny Gemma 3, 270 million parameters. If you happen to skip Phi, I don't blame you. Let's go to Gemma. Okay, so yeah, apparently nowadays you do also need to get agreement to use Gemma as well. I've been granted access to this model. You have to sign the terms, but I gather with Gemma, I've never heard of someone not being approved, but you might be the first. But let me know if there's any problems with it. But otherwise, it should be possible to come into Gemma. I discovered that you can't use quantization with this tiny Gemma model. I don't exactly know why, but I got some horrible PyTorch error when I tried, so I have rapidly turned that off, and it seems to be working fine now. So this should run hopefully a bit more quickly than 5.4. I can already see it's got half a gigabyte to download, of which it's halfway through. You can see it's executing down there on our T4. And then once that's done, we're going to do Qwen and then DeepSeek, and then we'll be done. I will come back in a second when this is ready. Okay, and so Gemma has finished, and Gemma's joke, tell a lighthearted joke for a room of data scientists, is why don't scientists ever go to the beach? And then Gemma stopped. So whatever Gemma had in mind, we will sadly never know. And similarly, it gives other random stuff if you run it. So you probably had the same experience. The fact that it even had an attempt at a setup is in itself admirable for a 270 million parameter model. Really very tiny indeed. Okay, that is Gemma. Moving on to Qwen. I have already run Qwen because this is, again, I think a larger variant of Qwen. So I let it do its downloading. Look at that. You can see that it brought in like 8 gigabytes or so. You can see as well my GPU RAM is really stuffed full. So here it says, tell a light-hearted joke for a room of data scientists. And it says, sure, here's a light-hearted data-savvy joke. Why did the data scientist break up with a statistician? Because of the correlation. It was just a coincidence they were always together, and it was not a strong enough p-value to justify staying together. So it's all right. It's like nerdy. I guess it's kind of, correlations and all that. I suppose we'll say that's all right performance from Qwen. And it wanted to keep going, but I stopped it after its 80 tokens. And then finally, I wanted to show you a reasoning model. So DeepSeek R1, it's the famous reasoning variant of DeepSeek. It's been compressed into a small 1.5 gigabyte version, 1.5 billion parameter version of Qwen. And I've said it can generate up to 500 tokens. And what you'll see is that the first thing it generates is the reasoning message, the thinking through. Okay, so I need to come up with a lighthearted joke for a room full of data scientists. Where do I start? Well, and off it goes. It rambles away. You can see lots of this stuff. And guess what else you can see? Wait. You can see maybe blah, 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 another angle. Or maybe wait, another thought. Or maybe something like alternatively. And you may remember when I told you before that just this slipping in the word wait is one of the tricks that are used. And I believe that alternatively is another. So you can see like wait, alternatively. And these tokens are slotted in there while it's in inference, token by token. That's thrown in there to force the model to self-reflect and keep going. But in this case, it kept agonizing over this joke. And even in 500 tokens, it wasn't able to come to a joke. So whilst we can have some insight in the thought process of a small model, we don't actually get a particular joke at the end of it. Maybe you did better. I'm not sure. Anyways, the conclusion is that open source models are super fun to experiment with and easy to run. Downloading them the first time can be a bit of a bore, but you get to use them. It's for free. And as a extra piece of information we've gleaned, they're not very good at telling jokes. But they're very good at lots of other stuff, and so you should experiment and try, find out things they're good at, because we are going to discover one of them tomorrow in the commercial project that we'll build, rather than this silliness. I think probably Llama 3.2 won the prize for today's session. Anyway, that is our exploration of open source models using the model part of the Transformers package. And as part of this, we really dug in to what it looks like to have a deep neural network in PyTorch code as part of the Hugging Face Transformers code. And that's a wrap on day 4 of week 3. We really did get more technical today. I hope you enjoyed it. Now, in addition to coding with frontier models, building assistants, you now can use Hugging Face pipelines, tokenizers, and models, and hopefully you're starting to build some intuition about how these things work, how they fit together. And tomorrow, we're just going to practice. Tomorrow it's going to be about really building up the strength of these skills, this expertise by some repetitive work of building stuff and hopefully a more useful commercial product than telling jokes. And we'll also be looking deeply into running inference. And I also have a little nice thing to show you. I just want to open your eyes a little bit more about how inference works, how it is that generating the next token ends up giving the kinds of outputs we see. So I want to show you something, a visual. For the visual people that feel like I've been doing too much coding, I've got something visual for you that I think you will like. And I've got that in store for you tomorrow as well, which will then wrap up week 3. I can't wait to see you for week 3, day 5 tomorrow.